So the next speaker is Professor Feng. He is a professor of the Department of Civil Engineering at Tsinghua University in China. Professor Feng received his Bachelor of Engineering degree and PhD degree from Tsinghua University. His research field is the high-performance structures and infrastructures with emerging materials and advanced construction techniques for civil engineering, including FRP structures and FRP strengthening, advanced concrete structures, and 3D printing for construction, integration of structures, and function for sustainable development. He has published more than 80 journal papers and has received more than 1,800 citations by Google Scholar. He has acted as the co-chair of 3 Chinese national standards committees. His research contributions have been recognized by many awards and prizes, including National Award for Science and Technology, Progress of China, a Young Scholar of Changjiang Scholars Program, Excellent Young Scientist Fund by NSFC, Mao Yixing Beijing Youth Science and Technology Award, and Young Scientist Award by CM. Professor Feng, please get started.
Many thanks for introduction, Professor Kushwins. And today I'm very happy to have this chance to give some our ideas to present here. And actually, my background is a structure. I'm did structure research about more than 15 years. About 5 years ago, I found 3D printing is very interesting technology for the construction. So I start. Mostly, I read the paper from Professor Kushnaris and started my research on 3D printing. Today, my presentation not just on 3D printing. Also, another hot topic is AI, artificial intelligence. We think the AI and the 3D printing technologies can change the existing structure design system. So here just present our idea and introduce some research recently. Okay, this is the outline. Firstly, I want to show some results about the publication. About 3 days ago, I made a search in the Web of Science database. We found more than 5,000 papers. The 3D printing in the title, totally, mostly in recent 3 years. But only 44 papers in construction, building technology, and engineering, civil engineering. This category, this catalog by the database, classified by the database. So this paper is very small percentage in the whole publications. So 3D printing in construction, not very, very hot in construction. This is the first result. And another result is the artificial intelligence in the title of the papers, more than 6,000 papers in Web of Science, and only 163 papers in this topic, in building, construction, building technology, and engineering, civil engineering. So it's better than 3D printing, but their intersection is 0. That means in the title with the the 3D printing on the AI at the same time is zero. No paper in this combine them together. So, but we think it's very important to combine them together. The first thing is we need review the 3D printing construction. We have our keynote speaker and Professor Jen have introduced the background. 3D printing have been developed a lot in construction. Use a different material, include concrete, steel, and clay and composites. And about 5 years ago, we studied the mechanical behavior of printed cementitious material. Firstly, we found the printed cementitious material has isotropic mechanical behavior. That means it weak in shear and in tension, and the strengths and the modulus are different in different directions. So we developed the constitution mode of the printed material. We have published a paper in CBM, and we found the weakness of the interlayer property of the printed material. We present a method, use the fiber reinforced polymer to strengthen the printed components. Just attach, bond the FRP, fiber reinforced polymer, on the surface. Because the FRP is very soft, flexible, can attach the surface very easily, and even can spread the short fiber and the resin on the surface to increase the mechanical behavior of 3D printed components. The results is very good. Okay, this is just the background of our research at the beginning. This is 2 papers published in CBM and the composite structures. And everybody will ask me, ask us, can we print buildings directly? Somebody say yes, because as the keynote shows, this is in China, this is in Russia. And somebody say no, because the print building, that means the machine should be larger than build. So the scale of the 3D printing machine is it's a big problem, it's a challenge. And another thing is actually nobody see the support for the horizontal beam slab is it's necessary for the structure. So my answer is to use 3D printing appropriately. That means we don't want to use 3D printing as a good technology. Actually, want to use we want to good use. Good use means use it appropriately. So what is the appropriately? Okay. Another keyword is about the AI technology. Actually, AI technology have been developed very quickly recently. Actually, it is based the machine learning technology. I don't want to say too much. You can understand it's a very good calculation method. And some research have been published use AI for construction to identify the crack and the vibration behavior. Use the AI. And my idea or my thought about the structure design use the AI and the 3D printing together. So this is our this is our the framework of the existing structure design system. Actually, the design of the existing structure is the iterative process. That we need to estimate the structure size and the strength, and calculate the behavior, and comparing the results with our requirements. And if the requirement cannot be fit, we need re-estimate the structure parameters and analyze again, use a finite analysis and use an experimental method such as. And actually, for the simple structure, we can use requirements parameters directly calculate the design parameters for the simple structure. For the complicated structure, it's very difficult. So now we can use AI method to get this process before we design or before we design a structure. We can use a finite element method to calculate a lot of the cases and use AI start the cases. But the start not from this direction, just the start from the result as the input and the design parameter as the output, as the cases for the AI study. So after the machine learning, we can input requirements parameters and get a design result. This is our basically concept, use AI for the structure. And we input the requirements, maybe we can get a very complicated structure. So we need a 3D printing to make it. So to make it. So this is a combine AI and 3D printing. Actually, we need consider change the existing structure design system, use AI and 3D printing. AI support the design process. 3D printing support the manufacture build process. With these two technologies, we can get more complicated structure. We can get more structural possibility. We can understand the complicated structure. What is the possibility? For example, this is just the illustration. For general things, we can, for now, we always start with the stress strain curves like this. This is a member. We can get the compression curve like this. Okay. If we make some holes in the specimens, we can test like this. And the different holes, we can get this. Always in this direction, we have specimens and get a curve, then get a curve. But if we want to get a curve like this, who can tell me what is the specimen's like? So this is a very, very complicated problem. The curve means possibility, but we can use AI technology to start a lot with the curve, firstly. Then, when we need a curve, the AI will give us the results for design. Okay, this is the first concept. Another concept is for existing structure manufacture method, this is very difficult to make it. Even you can imagine this structure have this behavior, but you cannot make it very easily. But 3D printing provides this approach. So AI gives the support for design, and the 3D printing gives the manufacturer support. Okay, this is our concept, and we can show some research on AI and the 3D printing. The first thing we did some application. Some cases we start from structure and use the finite element analysis, gather behavior, and use the behavior as an input, and get the design design parameter, and evaluate the design is good or not. And if it's good, we as an input another input cases, and training the AI program. For example, very simple example, just the steel plate, we use a different hole and a different size and different location, get the curves like this. And we start the curve as an input, and we can get the whole location size. This is a process. Actually it's just a AI program. We can. Okay, this is the results. At the beginning, it's not good. We input a lot of cases for study. They can get very accurate results. That means that you have a program. Just input the requirements, you can get the desired structure. You don't need to calculate. The AI program, like a people, like a engineer, have a lot of the experienced engineer can get the results very quickly. So this is the concept, first one. And another research is that we started the complex structure, and we printed a lot of the brick. A lot of brick get a lot of the behavior, and the behavior very complicated. And we want to find, if we want the curve like this, how to design the geometric. And we found some principles based on the study, and we can get a two-step behavior like this. Okay, and another research work use 3D printing. It's use 3D printing made the complex joints. Actually, for the traditional Chinese wood structure, have a lot of the complicated joints like this. It can make the very beautiful structure. And for the now, very few people can make the joint, but we have the 3D printer can make very complicated joints like this. And we have started the mechanical behavior. It looks very good. Okay, what does it mean? That means the possibility. Possibility means we can design a lot of the different joints. Okay. Okay, the time is very limited. After that, we can use a robot arm to assemble it. And this is by this KUKA robot arm by the Professor Xu in our university. They made the masonry wall like this. Okay. Finally, I want to just show a framework for the application screener. In general, we have mechanical behavior requirements, and we get the results and use the 3D printing of prefabrication. For the simple member, we can use the prefabrication, and for the complicated, we can use the 3D printing. And assemble them use a robot arm. Okay, so we can combine AI 3D printing together. I think the AI like the brain of the structure design, and the 3D printing like the arm, and 3D printing like the arm and the hand, the robot arm like the arm. So, and the design it, made it, and make them together. That is our concept. And actually, for the lunar basis design, for ESA, NASA, and our proposal, we use a 3D printed brick and a robot arm, make them together, just like the Professor Kushnaris said. Very similar concept, assembling them together, and use a different shape. Okay, this is finally the conclusion. We actually the main concept is that we want to use the AI and the 3D printing appropriately. This is the main concept, and in future, I just want to show this picture. About more than 2,000 years ago, we like this. Now we like this. After maybe 200 years, maybe something, even just 20 years, our construction just like this. Okay, time is very limited. I just show our main ideas very quickly. More discussion and questions are welcome. Thank you.